Hello again. We've got a point negative 3, 4 lying on a circle with a radius of 5 at some angle called B. So this point is going to be at about 3 units left and 4 units up. So we would say it's also on the circle, so I'm going to say it's somewhere about right here. What we can tell from that then is that this height here is going to be 4 because that's what the y value is. And this distance here is going to be 3. We'll call it negative 3 since we're going to the left. What we've got then here is a right angle, and so we've got 2 legs of a right triangle. Let's connect the point to the origin to make hypotenuse of the right triangle. This hypotenuse is going to have a length which is the same as the radius of the circle. The radius of the circle is 5, and so this hypotenuse will have a length of 5. We're told that this angle is called angle beta, and so this angle here will go from here to there. And that will be angle beta. We need to find all the trig functions that correspond to this angle. So we've got first sine of beta. Remember that sine is y over r, and so sine will be 4/5. Cosine of beta is x over r, so that will be negative 3. Look out there, it disappeared on me. Maybe it did on you. Negative 3 over 5, and then the tangent of beta will be y over x, which is 4 over negative 3, or negative 4/3. For the other 3 trig functions, those are reciprocals to the first 3. Cosecant is reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. So we've got all 6 trig functions right there. Next up, if we wanted to find the coordinates of a point on a circle, if we're given 2 things, the radius and the angle, we can use the following 2 formulas. The x-coordinate can be found by taking r and multiplying it by cosine of theta. We can also find y by taking r and multiplying it by the sine of theta. Now, where do we get these formulas from? Well, it comes from the fact that, remember that sine of theta is y over r. You take both sides and multiply it by r, and you get this formula over here. Same sort of thing to find that cosine formula, or to find that x formula. You would take cosine of theta equals x over r, multiply both sides by r. Next thing that I'd like you to do is recall the Pythagorean theorem. So in the Pythagorean theorem, we have the square of each of the 2 legs added together will equal the square of the hypotenuse. Now, that would be for a triangle, a right triangle, where these are called A, B, and C. But suppose I don't want to call them A, B, and C. Suppose that this is a point which is on a circle with the center here. And that's a pretty horrid circle, but I think you kind of get the idea. This point is on the circle. And this is the center. That would mean that this C is not C, but R, the radius of the circle. And then A and B are the y value and x value of the point. We'll just call this x squared and y squared. So this is the Pythagorean theorem, just using different variables. Now, let's use these 2 formulas, these 2 definitions of the x value and the y value.
Substituting in place of that x, we have our cosine of theta
squared. Do the same thing with that y. Plug r sine theta in place of y. Next, we'll square r times cosine theta. That would be r squared times cosine of theta squared. Now the way that we write cosine of theta squared is by putting a little 2 as an exponent above the word cosine. What that means is take the cosine of the angle and then square that number. Do the same thing here. And that equals r squared. Next up, I look at this left side and I can see that we can factor out r squared from those two terms. R squared cosine squared theta plus sine squared of theta equals r squared. Next up, I'm going to divide both sides by r squared. Since I've got a factor of r squared on the top and on the bottom, we can cancel those out, leaving me with cosine squared theta plus sine squared of theta. Divide the right side and we get 1. Now, I'm just going to change the order that we're adding over here. And write that as sine squared theta plus cosine squared theta equals 1. What we have here is a very famous, very useful identity. It's called the Pythagorean identity. It's based off the Pythagorean theorem. We're going to use this to help us solve problems in this class. Pythagorean, oops, spell this up here. Erase that. Pythagorean. It's named after the ancient Greek man named Pythagoras. Next example. We're told that the sine of theta is 3/7. Now I think of the sine and I think of y over r. And theta is in the second quadrant, so we want to find the cosine of theta. Alright, so this angle is in the second quadrant, meaning we've got an initial side here and the terminal side over here. That's our angle theta. And the sine is 3/7, meaning that if I form a reference triangle, drop down to the x-axis, then the ratio of the y to the r will be 3/7. Now we want to find out what the cosine is. So what we can do then is remember that cosine of theta is x over r. So I can find what this x value is here. Then I can take that, divide it by 7, and we'll have our cosine value. Now remember that this is a right triangle. So we can use Pythagorean theorem. 3 squared plus x squared equals 7 squared. So that'll be 9 plus x squared equals 49. Subtract 9 from both sides, and then square root both sides. So x is going to be, let me scroll a little bit. Alright, x is going to be the positive or negative square root of 40. And if we simplify that, I see that 40's got a perfect square factor of 4, so that's going to be plus or minus 2 root 10. And so this x value is going to be 2 root 10. And since it goes to the left, that's going to be negative 2 root 10. So x over r will be negative 2 root 10 over the r value, which is 7. So that's going to be our cosine of theta. Next up, we want to find the coordinates of the point on the circle, which has a radius of 6 and an angle of pi over 4. So since we want to find the coordinates, we can use those coordinate formulas from earlier. X equals r times cosine theta, and y equals r times sine of theta. Now, pi over 4 is 45 degrees. So I want to know, first off, what is the cosine of 45 degrees? 45 degrees is located here. Make that reference triangle. This is a 45, 45, 90. The side lengths are 1, 1, and root 2. So the cosine would be x over r, 1 over root 2. Now we need to multiply that by r, which it tells us in this problem is 6. So that's going to be 6 over root 2. Of course, we'll need to get that root out of the denominator by multiplying by root 2 over root 2, which is 6 root 2 over 2. Simplify the 6 over 2 and we'll get 3, and so the x value will be 3 root 2. Sine is the same thing. Now notice that the sine is y over r. Y over r is 1 over root 2, just like it was for the cosine. So it's going to simplify in the same way. Y will also be 3 root 2. So writing them as coordinates, we have 3 root 2, comma, 3 root 2. For this one, we're going to use the same formulas, r cosine theta and r sine theta. First, let's draw our angle. Initial side, 5 pi over 3 is 300 degrees. And so we'll go past 90, past 180, past 270, 30 degrees past 270, and this is going to be our 5 pi over 3. Our reference angle then is going to be a 60 degree angle, taking us from the terminal side up to the x-axis. So our triangle then will be a 30, 60, 90, with side lengths of 1, root 3, which will be negative because we're going down, and 2. Remember that the hypotenuse is always positive. So r times the cosine of theta is 5 times cosine. Now, cosine of this angle is x over r, so 1 over 2, which is 5/2. Then the sine of this angle will be y over r, negative root 3 over 2. So those are our two coordinates. That's negative. Let me fix that. There we go. Last problem. I'm going to put in a separate video. It shouldn't take too long, but I think it will take longer than the 45 seconds that I have left. So we'll pause things for the moment and see you in video number 2 next.